Well done, you've reached the end of the second week of the MOOC on concurrency in Erlang. I wanted to make a video just to feedback a few things that have come up this week, and one that came up from week 1 of the course. So first of all, in step 2.18, I talked about steps, and in the context of discussing concurrency. Now, I mean, just to reiterate a few things, Erlang's a concurrent language. That means it allows the possibility of things happening at the same time. It's not a parallel language. It doesn't force things to happen at the same time, which is, of course, I mean, there are languages that want to do that, and that's a useful thing to do. But concurrency is more at the design level. It's at the abstract level. It's saying these particular processes can evolve independently of each other and simply pass messages to each other to exchange data. Now, what that means is that we can run these processes on a single processor as long as we share time between them. And then there's a question about how we do that time sharing. And the answer is we can, because what we're doing is evaluating expressions or evaluating a series of expressions, we can think of counting the number of steps we take in a particular evaluation. For example, if we were adding up 2 plus 3 plus 4, we could say getting 2 plus 3 to 5 is one step, and adding 5 to 4 is another step. And so we've got this abstract model of steps, and as long as we ensure that every process that can run, every process that isn't sitting waiting to receive a message, every process that can run gets a fair share, then we can ensure that all those processes are evaluated, as it were, concurrently. And this is just like a time-sharing operating system, but it's doing that at the programming language level. But perhaps what I should have done was explain rather more clearly what I meant by a step, so apologies for that. The next thing I wanted to talk about was trapping exits. And in the discussion on step 2.5, there was a question about using the reason kill. Now, if you think about it, we really do need in the language a way of unambiguously being able to take down any particular process. And that's why if we send an exit signal to a particular process with reason kill, it will kill that process, even if that process is trapping exits. Now, that process will then send exit signals to linked processes, but the key thing is the reason for those will be killed and not kill. So if the other processes, the linked processes, are trapping exits, they will not be killed. So if you want to kill processes that are trapping exits, you have to kill each of them explicitly, individually. So it's difficult to do, but it is possible. And of course, we need that. We need to be able to take down a system if we have to, or take down a subsystem, so that we can restore things to a reasonable state, so we can restart things, for example. Final thing I wanted to talk about goes back to step 118. And Florian was talking in the comments there about trying to send functions in messages. And it looked initially as though he couldn't do that. He was getting a pattern match failure. And if you look at the code there, what you can see is, in fact, what he was doing was pattern matching against a bound variable in his loop. He was always matching against the fun variable, which would first time around get matched, and then in recursive calls would be matching that same value. So classic mistake, using a bound variable in a pattern match and failing, that pattern match failing because you're not passing in the same value as was passed the first time. So it's just nice to see that coming up, and he found the mistake, and there were some comments on it, but interesting to see that's one of the errors you can get when you are allowed to pattern match against bound variables. Okay, next week we're going to look at scaling things up, perhaps using Erlang distribution, but also we'll talk about the basics of OTP. the middleware layer that comes with Erlang, and allows you to take off-the-shelf components like a server. And so get yourself started building systems that much more quickly and that much more robustly. Okay, so that will be what's going on next week, but until then, goodbye.